You may have already written query projections in earlier versions of EF, or if you write SQL queries, you've very likely used them, unless every single one of your queries is select star. In EF Core, we can use query projections to shape the query that's sent to the database, which could very well include related data and the resulting objects. In EF Core, we use LINQ's select method to specify which properties of an object we want returned. If you're returning more than a single property, then you'll have to contain the new properties within a type. LINQ lets you do that even if what you're projecting doesn't match an existing type in your system, by using the new keyword and placing the list of properties in curly braces. This will return what's known in .NET as an anonymous type, but it will only be known to the method in which it's defined. Here I'm querying the authors, and in the LINQ select method, I'm creating a new type that will return the author ID and a name that's a combination of the first initial of the author's first name and their last name. And the result is a list of anonymous types whose properties are an int and a string. If you need to move those anonymous types outside of the method, you could cast them to a list of dynamic, which is a feature of .NET languages. Or you can create another class or even a struct in your app and then project into that. Now let's add the books property into this projection. In addition to the other two properties, I'm now bringing back the complete books property. Now the anonymous type is made up of an integer, a string, and a list of books. You can also navigate into a related object without bringing back its complete types. As an example, I've changed the last property, which was books, to just be a count of the books. And check out the sequel. The count is part of the query, not something that happens in memory after the fact. So EF Core is pretty clever with that. And in the results, now you can see I have an int, a string, and then another int that shows how many books there are. You can also do filters within a projection. So, for example, I'll do a filter on that books property. I'll append the where method on books to make sure that the query is only returning a count of books from the 1900s. That sounds so long ago, doesn't it? Another really important point about this: the anonymous type itself can't be tracked because the context doesn't comprehend it. But if it has properties that are recognized entities, those will be tracked. So, going back to the query that pulled back some properties from author and the author's books collection, let's run it again and check the debug view after the query is executed. All it knows about is the books, because those are known entities. The other properties in the type don't mean anything to the change tracker because they're not part of the data model. That is something really good to be aware of. Eager loading is great for querying graphs, but sometimes you already have an object in memory and want to get its related data. You can always use the same dbContext instance to execute another query and let the change tracker take care of wiring up the related data. But there are two other ways to perform this task, which we refer to as loading. And EF Core's ways to do this are called explicit loading and lazy loading. One way is to do it explicitly through the context using the dbContext entry method along with its load method. You can pass in the object that you already have in memory and then tell the context to load either a collection property such as books or a reference property. For example, if you have a book and you want to get its author. I'll start by retrieving an author into memory. And once it's in memory, I can use the context's entry method, pass in that author object that I want to load from, then append the collection method along with a lambda for that author's books property, and finally I'll execute that with the load method. I'll stick a breakpoint in here so that I can look at the author before I load the books. And then I'll run it, and right now author has 0 books. But then after I call the load method, that same author now has 2 books attached. And there's the SQL command that the load method caused to get sent to the database. And once that book data came back, the change tracker started tracking it, and it made sure that those books got pushed into the books property of the author. Keep in mind that you can only call load on a single object, so you wouldn't be able to use it for a list of authors. In the case that you want to do that, The coding might be easier and the performance might even be better to just execute another LINQ query instead of iterating through that list and loading related data for each author. That's something you'd have to determine by profiling your code and checking performance. One last point I want to make sure you know about explicit loading is that you can filter collections using a query method, just like I'm doing in this example here. The other way to load related data after the fact is what's called lazy loading. Like the explicit loading, it lets you get related data for objects that are already in memory. But lazy loading does it on the fly. I'm personally not a big fan of lazy loading because it's so easy to accidentally abuse it and create performance problems or get unexpected results. Fortunately, lazy loading is disabled by default in EF Core. That's because it's so easy to trigger that the EF Core team wants to make sure that you've been very explicit about enabling it. Once it's enabled, lazy loading works implicitly, and it's really easy to use. It works without the ceremony of coding up the explicit loading. All you have to do is make some reference to that navigation from the existing object. And as long as you've got a DB context in scope, that will immediately trigger the lazy loading, just like when we called the load method on the entry. So how do you enable it? First, every single navigation property in the model has to be marked virtual. Every single one. Second, you need to add the Microsoft Entity Framework Proxies package to your project. And third, in the DB context class, you need to tell the options builder to use lazy loading proxies. Here's the code to do that. I don't want to spend a lot of time on this topic, but I do want to warn you about some of the common problems you could run into. First, I should at least say something nice about it. As I already said, it does make it so easy to load data once you've got everything set up. Now let's look at some of the common mistakes people make with lazy loading. First is when using an aggregate method such as count on the reference property, EF Core won't just go get the count, it will send SQL to retrieve all of the complete book objects for that author. Then it will add each of those to the change tracker, and then, in memory, it will apply the count method and give you the result. If you're not profiling the SQL, you might never know about this until that author has written 2,000 books and the app gets really slow. Another common mistake happens with data binding. For example, a developer will retrieve a list of authors in a query and bind them to a data grid. And then when setting the properties of that grid's columns, maybe set one of them to the author's books property, perhaps again using books.count. And doing that knowing that lazy loading will go ahead and take care of that. But this causes a performance issue because the lazy load happens for each of the rows. This is referred to as an n+1 query, when one query triggers a number of other queries. And again, this is something you might not notice if you're not profiling your database, and then eventually performance gets really bad. The last gotcha I want to point out is that lazy loading is dependent on there being a DB context in scope to do that loading for you. So if you've used a context to query authors and then disposed the context and then made a reference to the author's books, there's no context there to do the job. So in response, you'll get 0 books and might be fooled into thinking that that author has not written any books, or that customer has not added any items to their shopping cart. So you can see why I prefer to steer new users of EF Core away from lazy loading until they really spend some time understanding how it works, because there are so many ways to accidentally misuse it. With more expertise, it can be a really valuable tool in your arsenal. So far, the focus for the retrieval has been on pulling back related objects. You can also take advantage of related data for querying, even if you don't want to retrieve those related objects. Here's a simple example of that where I want to retrieve any author that has published a book since 2015. I don't need the books, I just want to see those newer authors. So I'm able to navigate through the relationship in my where predicate, Then do a subquery of the author's books where I'm determining if any of their books have a published date whose year is greater than or equal to 2015. Entity Framework and the SQL Server Provider transform that link query into this SQL where exists query. It's only selecting the properties that make up the author, but in the where predicate, it is looking at the author's books. You can see in the results that I just got back the 2 authors, and these are the authors who happen to have newer books. But I've only gotten the authors. Notice that their books collections are empty because that's all I asked for. I used a where link method and an any method in my subquery, but you can use all sorts of link methods to compose this type of query, where the related data is used to filter or sort the main object. Depending on how creative you need to get, it's always good to profile the resulting queries in the database, just in case it can be written more efficiently with a procedure or a view.